Hello, are we recording now? Right. So let's start question 4.3 homework 3.4. We start by creating a new schematic, and we want to quickly create the circuit. You start by creating a voltage, a resistance, a resistor, another resistor, C capacitance, and L for inductance. You place wires. So this is a simple circuit. You can directly define the variables. And so for the inductance, the value is 0.5, capacitance 2. Those are very unrealistic variables. Capacitor of 2 will be huge, and the inductor of 0.5. Inductor is reasonable, but the capacitor of 2 farads, it's not very common in components I have dealt with. What about the source? We mentioned that there are two ways to define a pulse function. Sorry, U function. The first of which is used to use a pulse. This one has some advantages and disadvantages. So this is a pulse function, and you will just create one huge pulse of 10 seconds. So this will be your input. Another way is to define your input using points. But the problem in this, we cannot define it for your U function will have to start at a positive time. It cannot start at 0. So we'll start by mentioning that at 0, or we can try something out. So you can write at 0, 0.0000001. Your signal is 0. Uh, 0, while at 0.002, your signal is 10, and at 15, your signal remains still 10. So this is like a sort of a shortcut. Unfortunately, you cannot define the signal at a small value. You can actually go for 0 and 0.0. So something like this will do. Just press OK. Go for move. Move it here. Don't forget the ground. What kind of simulation are we gonna do? We're gonna do a DC simulation, a transient simulation. Stop time is 10. That's it. Just run. Oh, just run. First, check for our source. Yeah, it's a unit function, and it does make sense. So currently, we want to measure the power across all of the elements. There is one trick to this. So during class, we mentioned that to calculate the power, you pick the voltage, put the voltage across the element versus voltage through the element versus it's multiplied by the current across the element and multiply them together. So let's test this out. So voltage times IR2. So that's a good power. Oh, so that's our power. What does it mean for a power to be negative? Uh, it's not very meaningful because the way the software understands power is that it's absorbed or provided. So this means that we need the power to basically we just need the power to be positive. So or like you can't safely give the power a negative sign. Like this is just for notation purposes. So you can put negative V node 1 times R2. You can just keep it negative or positive, or just note this during your explanation. There is another tool. If you don't want to really think about it, and you want something automatically, you can just use Alt and pick an element, or Alt for the resistance. So yeah, as you can see, when you press Alt and select an element, it automatically understands that this is power, and it gives it a negative sign for the resistance. But for capacitance and inductance, it's just the voltage times current. Let's try this resistor by pressing Alt. All right. So you notice that for this element, the voltage is a difference between 2 volts. So V node 2 minus V node 1. Yeah, so it's a negative as well, because if it was positive, it will be V node 1 minus V node 2. Um, what So that's for you, as for your answer, or as for what we discussed in today's meeting, or should be enough for our follow-up. Please explain, why do you think power looks the way it does? Why does the power, or the capacitance, or the inductance start the way they do? What's the difference between the power in the resistance and the power in the capacitance and inductance? What happens after, in the beginning of the 10 seconds versus in the end? Just like feel free to explain as much as you can. So I think that's it. Thank you.